An AI system read a math proof that had already been published and passed peer review and found a hole in it. A real gap in the argument that the human reviewers looked right past.
Hang on. Published. Peer-reviewed. Isn't that the whole point? Other experts already checked it. How does a proof with a hole get all the way through?
That's exactly what most of us assume, Tyler. A proof in a top venue has been read by careful people, so it must be right. And usually it is. But here's the crack in that idea. A wrong argument doesn't have to look wrong. It can read beautifully, flow step by step, and bury one bad move so deep that nobody notices.
And that only gets scarier now that AI is writing proofs too. Every week there's a headline that AI cracked some big problem. Can you actually trust any of it?
That's the whole worry. So a team of researchers built something to fight it. A regular coding AI running on a flat monthly subscription anyone could buy. Its job, take a human math proof and rewrite it as computer code. And the machine that runs that code is ruthless. The code either runs or it breaks. No opinions, no benefit of the doubt.
So if it runs, the proof is correct. Full stop, no arguing.
Full stop, no referee needed. They pointed it at a handful of recent research papers. 4 of them checked out clean. The 5th is the one you'll remember. And keep one odd little picture in your head. 1 triangle and 10 scattered dots. That doodle is what cracked a published proof.
All right, and you told me to guess the cost. I'm picturing a warehouse of servers, so a few $1,000s a problem?
Hold that number. First, the clever part. The machine has a dictionary of math it already knows. But cutting-edge research uses words that dictionary has never heard. So the AI has to invent those words itself, define from scratch what some brand new mathematical object even is.
And if it defines it wrong?
Then everything built on top is quietly poisoned, and nothing complains because the code still runs. So they borrowed a habit from software engineers. When a programmer writes new code, they can't prove it's perfect, so they write little tests. Simple facts that should obviously be true if the code works. 2 plus 2 should give 4. Same move here. After the AI invents a new math word, it writes little facts that should be true of it and tries to prove them. If those fail, the definition is probably broken, so rebuild it.
So it's basically unit testing math, Bella.
That's the whole idea. Define your building blocks, test each one, and let a manager AI reorder and redo things when a later step shows an early choice was wrong. Now, the 5th paper. Everything checked out except one single step. The AI just could not make that step run. Keep that stuck step in mind because it's the key to what happens next.
So why couldn't it? Bad translation on the AI's end? It fumbled its own code?
That's what you'd expect. The machine tripped over itself. So they looked closely, and the step didn't fail because the AI got it wrong. It failed because the published proof was wrong.
Wait, the proof itself.
The proof itself. And the AI didn't just shrug and quit, it handed over the receipt. Remember that doodle? 1 triangle and 10 scattered dots. That's it. That little arrangement is a perfectly legal case for the theorem, and it breaks the exact step the proof leans on. One line secretly assumed something that isn't always true. Hand checkable. You could work it out on a napkin.
Okay, and the cost? I guessed thousands. Please tell me I was wrong.
Way off. About $5 a problem, on a subscription anyone could buy. Rival setups renting whole rooms of GPUs were burning over $100 each. And on a batch of brutal contest problems, this thing solved all 32 it drew.
One thing, though, and it matters. Finding a hole in the proof doesn't mean the answer is wrong. It's less the bridge is unsafe and more the blueprint's math doesn't add up. The bridge might be perfectly fine. This particular argument for it just isn't.
Exactly right. And the authors say so plainly, the theorem may well be true. What the AI became wasn't a genius mathematician. It became a tireless, literal-minded referee that won't let a single step slide.
So here's what I keep chewing on. Would you trust a math result more if a machine like this checked every step? Or less, once you know it just caught something a whole room of human experts missed? Drop where you land.
And if you like watching fresh AI research get pulled apart into plain English, subscribe. There's always another surprising one loading up next.
1 triangle, 10 dots, and a proof that fooled everyone but the machine. So who's really doing the checking now?